Blender key.
Alright, in this tutorial I'm going to show you the basics of the molecular script add-on. If you don't already understand how to use the particle system, I would highly suggest learning the particle system, or at least learning a rudimentary understanding of the particle system before you move on to the molecular script. Because I'm going to go at this under the assumption that you already have at least a basic understanding of the particle system. If by some chance you have not really messed with the particle system, I will have a link in the description of this video to a intro to the particle system, and that will show you the basics of what you need to learn or need to know in order to understand how to use the molecular script. Alright, now let's go ahead and get started. I'm going to add this link in the description, and this is where you can download the updated version of the molecular script that's for Blender 2.8. Just download the version that matches your operating system, and then install it like you would any other add-on. Alright, before we get started, there's two specific types of molecular script simulations. There are free particles, and then there are linked particles. If they're free particles, they're basically just particles that have their own destiny, I guess you could say. Once the particle is created, they go wherever physics guides them. You know, kind of like chaos. But if they're linked, then they're kind of glued together. I hope that makes sense. Alright. Now, I'm going to use this cube to create a molecular script simulation. I'm going to go ahead and press G for grab, and then Z to move it up on the Z axis, and then I'm going to go ahead and add a floor. Add mesh, plane, floor, scale it up, Control A to apply the scale, which it's important to apply the scale anytime you're dealing with physics objects. Anytime you change the size of an object that's a physics object, you need to apply the scale. It will glitch sometimes if you don't do that. Alright, now with the floor selected, we need to tell Blender that we intend this to be a collision object, something that particles can impact. So we come over here to the physics tab and then click collision. And then you have a couple of settings over here, and the biggest one that you'll mess with is dampening. When a particle hits it, if you want it to bounce and never stop bouncing, keep the dampening to 0. If you want the particles to hit it and then just stop and no bounce whatsoever, you turn it up to 1. Now I want it to have a little bounce, so I'm just going to press 0.5. Alright. Now I'm going to go to the cube. I'm going to apply a particle system to it. Click on the particle system, click plus, and then I want this to generate, let's say, this is going to be an example of free particles. And this is going to look the most like the actual particle system. But we're going to use molecular script. Now I'm going to generate 10,000 particles. And I want to generate it over 200 frames. And I want the source to be the volume. And let's see, physics. Leave physics alone. Don't really need to mess with that. And then come down here to molecular script. And that's pretty much it. Now, if I press play right here, only thing you're going to see is the see how the particle system would run this. But since we're using the molecular script, we have to use this button down here. Now if I press start, it's basically just generating particles. They're hitting. Now you can see the particles disappearing, and that's because way up here the lifetime is set to 50. So I'm going to go ahead and turn the lifetime up to a high number. That way they stick around. And press start again, and here we go. And the particles are just hitting the floor and bouncing up. But if we look closely, the particles are halfway going through the floor. We don't want that. If we was doing a fluid simulation, that'd be fine. But when it comes to molecular script, we don't really want that. So we do need to go to the physics area, and down here where it says deflection, check size deflect. Now if we go back down here, click start. Now the particles are acting like little balls, little bitty balls hitting the floor, bounce a little bit, and then then they start to kind of roll away. Alright, now that's basically freestanding molecular script particles. That's the simplest. Alright, but let's just say instead of this cube generating a bunch of particles over 200 frames, we wanted to create like a cube shape lattice of particles. So let's just press 1 to go on the front side view, press 5 to go into orthographic view, press Z to go into wireframe, and then if we come up here to the top, and we want it to generate all the particles in frame 1. So we're going to put the frame start time at 1 and the end time at 1. That way all the particles are generated right away. We want the volume to be the source, and we want the distribution to be created by a grid. And the reason why we want it to be a grid is because we want it to be uniform and easily manipulatable, if that makes any sense. Alright, we want to, first thing I'm going to do is come down here to the render and viewport settings. I'm going to change the viewport to circle. That way we can just get a better look at it. Alright, now it just happens to be that this is the right size down here so that we don't actually have to adjust the size. I mean, otherwise we may have to make them bigger or smaller so that they're not overlapping. But 0.1 just happened to be the right amount. So up here in the render section, we need to change the scale also to 0.1. And then change this from halo to object. And then that we need to create an instancing object. And in this case, we want our particles to be an icosphere. So I'm going to click add mesh and then icosphere. And then this icosphere, we don't really need it except for it to exist. So I'm just going to grab it on the x-axis and just move over here out of the way. And I'm going to go ahead and apply a material to that. Now I'm going to go back to the cube. Go back into the particle settings. And then right here where it says instance object, I'm going to set it to icosphere. That way See, like if I go down here to the viewport display and then change this to rendered, then we can see the icosphere. Alright. But I'm just going to leave it on circle because it calculates quicker. Alright. Now, down here, we got something called activate self collision, which we definitely want the particles to be able to bounce off each other. So we definitely want that. And I always check this one as well. That way if we have more than one emitter, then the particles can bounce off of each other from different emitters. And that's what this bottom check mark will do. Now we want to link these particles together. Activate particle linking and activate particle linking with others. This right here is like if we had more than one emitter where these particles from this emitter and another emitter could link with each other. That's kind of a more advanced thing than I'm going to get into here. It's something that you will figure out on your own, trust me. Alright, now with the linking, there seems to be a magic number when it comes to particle linking. And that magic number happens to be 3.5. Don't ask me why, but in almost every case, that is the best balance between the search distance and the number of links that makes it stable but doesn't slow down the computer so much. Alright. Now what this is actually doing, I'm going to explain what it's doing. Like, let's just use this particle as an example. It means it's going to look out 3.5 diameters. And the diameter is the diameter of a particle. So it's going to go 1, 2, 3.5. And it's going to look out that far for other particles to link to. And then this is the maximum number of particles that it can link to. And then this right here, which is important, this is the amount of distance that each particle can be, that each link can be stretched before it breaks. And it's set to 0.5, which means, let's assume this particle is linked to this particle. It means that these particles can move roughly this distance from here to here apart from each other before the link will break. I hope that makes sense. Alright. And then right here, new linking at collision. Basically, let's just assume that some of these particles broke loose and then they bounced into other particles. This would control the likelihood those particles would create new links. If you have it set to 0%, no new links will be created. If you have it set to 100%, every time there is a new particle collision, a new link will be created. And then down here you have the same settings as you have up here. Alright, now if we press play, now we can't press play right here. We'll have to click Start Molecular Simulation. See, it kind of just bounces. And it's held together. It's actually kind of neat. It's kind of squishy and fun, in my opinion. Alright. Simple enough. But suppose you don't want it that squashy. What you want to do to make it stiffer, you can turn this up, the substeps, up to about, let's say, 20. Let me turn this down to 50 so it simulates quicker. Now, whenever it hits, it should be stiffer because there's 20 substeps. It didn't flex as much, but it still bounced. Now if I press play, you can see it in real time. See, it's a lot more dense. Like it's still bouncy, but it's stiff. Now let's assume that I want it to be kind of brittle. What I want to do is come up here to the breaking distance. Let's say I want to turn this down to 0.1. And I want to go ahead and come up here to the dampening and turn the dampening up to 0.9. That way it's a little bit more stable. Excuse me. I got a little bit of code. Alright. Now if I press start, let me go ahead and click Freebake. And then start molecular script simulation again. And this time it should... It has a little bit of a wobble to it. Now let me go ahead and turn this down to 10. Because I'm trying to make this look more brittle. See, it kind of crushed at the bottom. Alright, but it's still got quite a bit of elasticity to it. So I'm going to change this to 0.025. That way it can only stretch 1/4 of the amount it could before. And then I'm going to turn this up back up to 20. Because I'm trying to find that balance where it kind of crushes a little bit. There you go. Kind of doing it. You have to play around with this a lot because there's no exact way to go about it. It's all to a degree trial and error, but after a while you'll have a pretty good idea of what you need to start at. Turn this up to 30 and then change this to 0.01. Now it's going to be a little bit slower because I got 30 subframes. And it's stuff like this is why the molecular script will take a long time to get used to, and it takes a long time to get it just right. But as you can see what I mean? It's kind of brittle at the bottom, and it doesn't have a whole lot of elasticity to it. You'll be able to see it better here. See what I mean? Now, pretty much any object can be filled with particles, or you know, create out of particles using the molecular script. And all these settings, it's going to take a long time to kind of get used to get proficient with. I know it took me a long time, and I'm still learning stuff. But the biggest thing that you need to learn, or you need to be aware of, is whenever you're creating the particles, make sure that they do not overlap. Because if they overlap, you can kind of get by with it if it overlaps just slightly. But if it overlaps, let's just say that much, it will probably do crazy things. Now, it won't if you just had the viewport set so that it's overlapping, because it's calculating the physics based off of the rendered. But let's see, I turn this one up to the same amount, and then let's say I go ahead and come down here, free bake, start simulation. See how it kind of just flies apart now? It doesn't hold together because upon impact it just goes nuts basically whenever you have intersecting particles. So you definitely do not want particles that are intersecting with each other. Alright, what else? Well, that's actually pretty much it, but let's just say I want to look through the camera. See what that looks like. If you want to see this in real time, you have to go to the particle systems, and down here where it says viewport display, change it from circle to rendered, and then you can actually see what it looks like. And if you want to change the color of the particles, you go to your icosphere, and whatever material you have for your icosphere, that's the material that you'll see as your particles. Alright, if you have any questions, leave a comment below and I will try to answer, because I know I'm probably glossing over so much stuff. But this is basically the basics. If you can understand how all of this is working, then the rest is just your imagination. But anyway, thanks for watching. Later, people. Thank you for watching this video. Here are 4 other videos you might like. If you liked this video, please give it a like, share it, or leave a comment. I try to respond to every comment on every video, regardless how old the video is. Also, please support your favorite YouTubers by disabling ad blocker. Thanks again. Later.